The time has come for robots to step up and face China's ongoing threat. To that end, the US is gearing up to deploy a robot army. Everyone knows that being a soldier is an iconic job, but some of the tasks that soldiers must do are more dangerous than others. Walking through minefields, deactivating unexploded bombs, or clearing out hostile buildings are some of the hazardous tasks of soldiers in line of duty. Although the idea is to send robots into armed conflict instead of humans, that way, we would only lose the money it costs to build the robotic technology, not human lives. However, many people wonder whether removing the human element from war will make it even more inhumane. So it's asked, how much of robotic welfare is beneficial? Join us as we uncover how the US just launched their robotic army. The US military has been developing robotic systems for all sorts of jobs for years now, and some of them were even on the front lines in Iraq. The Terminator showed us a future where battalions of sentient humanoid robots wage war on mankind. While that vision is still well within science fiction, many countries, including the United States, have now looked into creating robot soldiers. In fact, in 2001, the Floyd D. Spence National Defense Authorization Act set a goal for the U.S. Armed Forces to develop an unmanned combat vehicle force that would account for 1/3 of all vehicles in operation. The Future Combat Systems, FCS, plan of the U.S. Army aims to upgrade the military systems of the country's armed forces. The FCS plan involves a comprehensive strategy covering all military branches. The plan proposes an integrated battle system that includes a fleet of different vehicles having up to 80% of the same parts. The plan also includes new unattended sensors that can collect intelligence in the field, unmanned launch systems capable of firing missiles at enemies outside the line of sight, and other various robots. With the creation of the robot army now set into motion, the mission is to program them to carry out the most challenging assignments, place them in dangerous missions, and remove humans from the equation. Along with building smart machines that will make difficult decisions immediately, the United States hopes to keep the budget down. The robots were also developed in such a way that if a member of the vast robot army were terminated, it wouldn't come at a great financial cost, with another able to step into its place while even more were molded at factories. And the army won't just be a marching one, as revealed in the plans to develop them for land, sea, and air. The P-Bot is a humanoid robot that can fly an airplane just like a human pilot. It is equipped with external cameras to monitor various essential flight parameters within the aircraft. The cockpit is designed for humans, but the robot can manipulate all its single controls. With the help of large language models, P-Bot can memorize intricate manuals to enhance its versatility across various aircraft. Its capacity is so vast that the robot can store all of the Jeppesen Aeronautical Global Navigation charts, a task that proves impossible for human pilots. Although humans can fly numerous airplanes but must study to hone their skills, transitioning to different airplane models often requires additional qualifications. A robot pilot can learn the configuration of several aircraft types at once. So, when it's time to operate a specific model, it needs to be programmed with the relevant instructions thanks to recent advancements in large language models. Also, P-Bot computer brains are more sophisticated with artificial intelligence, AI, and machine learning. AI is a form of computer program that allows the robot to process information and make decisions independently. Increasingly, the military is introducing autonomous systems that prepare attack plans independently, but require human consent before proceeding. These robots are generally called Lethal Autonomous Weapons Systems, LAWS. Although the research team created its first pilot robot prototype in 2016, AI technology was not very advanced at the time, resulting in a basic invention that could not be learned from literature or manuals. However, due to the rise of systems like ChatGPT and other large language models, P-Bot is a huge success. By leveraging large language models, Piebot is expected to execute error-free flights that can react to emergencies faster than its human counterparts. The robot can memorize aircraft operation and emergency manuals, such as the Quick Reference Handbook, an in-flight manual for flight crews to consult in case of mid-flight issues. It can also offer immediate responses and real-time calculations for a safe route based on the aircraft's airborne status. Furthermore, the research team is actively developing and testing its own natural language model designed to function without an internet connection. This tailred model will specifically address robot piloting-related queries and data. The language model will be stored on board the computer for easy access. When plugged in, the pilot robot can communicate directly with an aircraft. Its current design is tailored for use in scenarios where human involvement might be dangerous. Through voice synthesis, Piebot can effectively interact with air traffic controllers and individuals in the cockpit, allowing it to assume the roles of a pilot or first officer. Beyond aviation, the robot can seamlessly substitute humans in various capacities, such as driving cars, operating tanks, or even commanding ships at sea. According to Shim, Piebot can be deployed wherever a human occupies a seat and undertakes tasks. Moreover, the team deliberately designed Piebot with a human structure because working environments are made for humans. While its human form may not be maximally efficient, Shim says it is the most optimal. However, the most common robots currently in use by the military are small, flat robots mounted on miniature tank treads. These unmanned ground vehicles are able to tackle rough terrain and usually have a variety of sensors built in, including audio and video surveillance and chemical detection. These robots are versatile, with different sensor or weapon packages available that mount to the main chassis. Virtually all of them are man-portable. The Talon is a man-portable robot operating on small treads. In its base configuration, it weighs less than 100 pounds, 45 kilograms. Talon is operated with a joystick control, has 7 speed settings, and has a top speed of 6 feet by 1.8 meters per second. It can use its treads to climb stairs, maneuver through rubble, and even take on snow. Versatility has also been designed into the Talon, with multiple possible configurations that adapt the robot to the situation. The basic Talon includes audio and video listening devices and a mechanical arm. A lightweight version of 60 pounds or 27 kilograms omits the arm. Talons were used for search and rescue at WTC Ground Zero, and they have been used in Bosnia, Afghanistan, and Iraq for the disposal of live grenades, improvised explosive devices, and other dangerous explosives. Recently, the Talon was prepared to take on an even bigger role. All Talons are now equipped with chemical, gas, temperature, and radiation sensors. The military is even running tests on Talons that carry guns. Talon robots can be configured with M240 or M249 machine guns or Barrett 50 caliber rifles, according to manufacturer Foster Miller. The Packbot is another small robot that operates on treads. It's even smaller and lighter than the Talon, weighing about 40 pounds, which is 18 kilograms in the basic Scout configuration. The Packbot is man-portable and designed to fit into the U.S. Army's new standard pack, the Modular Lightweight Load-Carrying Equipment, MOLLE. Controlled by a Pentium processor designed to withstand rough treatment, Packbot's chassis has a GPS, an electronic compass, and temperature sensors built in. Packbot manufacturer iRobot says Packbot can move more than 8 MEP 13 cape, be deployed in minutes, and withstand a 6-foot, 1.8-meter drop onto concrete, the equivalent of 400 kilograms of force. Also, the U.S. soldiers regularly take advantage of this ruggedness, tossing Packbot through windows of hostile buildings and then using it to find out where enemies are hiding. Even if Packbot lands upside down, it can right itself using powerful treaded flippers, which also help it climb obstacles. Another is Matilda, which stands for Mesa Associates Tactical Integrated Light Force Deployment Assembly. Mesa Robotics made it, and is similar to other small robot designs, but has a higher profile due to its triangular tread shape. It weighs 61 pounds and is 28 kilograms with batteries, can be carried by 1 or 2 people, and fits in the trunk of a car. Matilda has numerous possible configurations. For instance, it can be equipped with a mechanical arm or various cameras and sensors, and even tow a small trailer. The robot's top speed is 3 feet, 1 meter per second, and its single-charge run time is 4 to 6 hours. In the event of tread damage, the quick-change tracks can be swapped in about 5 minutes. The Mule and ARV vehicles might begin a new kind of warfare. There are 3 proposed versions of the Mule, all of which will roll around on wheels. 2 variants. A vehicle that could carry more than a ton of equipment and designed to detect and turn off anti-tank landmines are similar to current military robots. The third variation is an armed robotic vehicle assault light, ARVAL, device. It will have reconnaissance, surveillance, target acquisition, and RSTA, as well as package and integrated weapons. In other words, this robot is similar to a human soldier who can engage the enemy in combat. ARV robots are less like soldiers and more like tanks. In fact, the Army intends to use ARVA robots to support manned vehicle missions. A tank squadron commander could use ARVA robots to extend his team's area of influence without the need for more soldiers. The robots could take the most dangerous positions and provide support whenever the manned vehicles enter a combat situation. Ideally, robot soldiers could achieve the same military goals a human group could manage. They'll have to be autonomous and able to identify targets, distinguish between friendly and enemy forces, engage the enemy, and interact with others in ways beyond simply firing a weapon. Right now, most robots are controlled remotely by a human being at a command station, though some robots have limited autonomy and can get from point A to point B with minimal supervision. For a robot army to be an effective fighting force, it would be best if individual robots could assess situations and make decisions without relying on human input. The Army continues to work with government agencies like NASA, universities, and corporations to push for more research to achieve this goal. The Autonomous Navigation System, ANS project, is part of the Future Combat Systems program. ANS aims to create a modular navigation system that technicians can install in all unmanned and manned ground vehicles. The system will include navigation sensors, global positioning systems, GPS, inertial navigation systems, INS, perception sensors, and collision detection software. One major concern for the military and engineers is the chance that a robot malfunctions. The possibility of a robot firing on friendly forces or innocent bystanders is often a part of discussions about using armed robots. It might seem paranoid, but malfunctioning robots have caused scares. In 1993, a bomb squad robot in San Francisco malfunctioned while on a mission to disable a bomb. The robot began to spin uncontrollably just before it could grasp the explosive device. Fortunately, the robot didn't cause the device to detonate. Military officials say that the goal of using unmanned vehicles and robots is to engage in combat without risking human casualties, or at least human casualties on our side. Another benefit is that even though robots are expensive, they may be cheaper than fielding human soldiers. Robots require maintenance but don't need health or retirement benefits. They might also be able to serve longer terms than human soldiers could. Many believe robots will never completely replace human soldiers, but they will be used in dangerous or tedious missions. A robot soldier will never be bored, so it's ideal for guard duty or long-term surveillance missions. South Korea plans to use robots to patrol its border with North Korea. The robots are called intelligent surveillance and guard robots, and they use regular and infrared cameras to detect intruders up to 2.5 miles away. The robots can pursue a target demanding a coded access number once they're within 10 meters of the intruder. The robot could sound an alarm or fire a weapon at the intruder if the target can't give the correct code. Currently, there are robots on the market that can carry and fire weapons like shotguns, pepper spray, grenade launchers, or even Hellfire missiles. The Mule ARVAL robot can fire a line-of-sight gun and anti-tank weaponry. Remote-controlled Talon robots can carry everything from an M240 machine gun to a .50 caliber rifle to grenades and rocket launchers. The South Korean patrol robot can either fire non-lethal rubber bullets at intruders or carry a K3 machine gun, a light machine gun similar to the M249. The U.S. Marine Corps Gladiator Tactical Unmanned Ground Vehicle, TUGV, can also carry an arsenal of lethal and non-lethal weapons, including shoulder-launched, multi-purpose assault weapons, SMAW designed to destroy bunkers, disable armored vehicles, and breakthrough fortifications, M240 or M249 machine guns, light vehicle obscurant, smoke system, LVOSS, a device that launches smoke grenades. Similarly, the anti-personnel obstacle breaching system, APOBS, a rocket that tows a line connected to fragmentation grenades, is designed to destroy obstacles like landmines. A large, heavy robot could handle weapons that are too cumbersome, heavy, dangerous, or powerful for humans. The ARVA could carry a medium-caliber cannon, a missile, and a heavy machine gun system. The Army intends to use robots like the ARVA primarily to support manned vehicles, so the armament must be comparable to a tank's. Other tools will include sensors and cameras, allowing the robots to perceive and navigate various hazardous environments. Robots like the Gladiator will have thermal imaging cameras, devices that detect heat and produce images that humans can see. Most robots will also have normal video cameras as well. A major goal of the FCS project is to create a universal platform that the Army and other forces can incorporate into military systems from now on. One of the challenges the military has faced over the years is that it relies on a mix of equipment, vehicles, and software that aren't integrated, making battle coordination and tactical discussions difficult. Ideally, all military robots will share a common platform, allowing officers to rely on multiple robots in a complex mission. For example, unmanned aerial vehicles could keep an area under surveillance, broadcasting information to unmanned ground vehicles as they enter the area. The first barrier to a fully functional robot army is technical. No one has created a reliable, effective way to make robots truly autonomous. However, scientists have made significant progress over the last several years. The Defense Advanced Research Projects Agency, DARPA, a research and development division of the Department of Defense, DoD, issued a $1 million challenge in 2004 to technicians and engineers across the United States to create a robotic vehicle that could navigate autonomously through a 200-mile course. Although 15 vehicles entered the race, none crossed the finish line. However, a team of engineers from Stanford University won the grand prize of $2 million when their autonomous vehicle completed the 132-mile course in 6 hours and 53 minutes. 3 other robots completed the course under the 10-hour time limit. The contest proved that it's possible to build a robot that can move across terrain on its own at speeds comparable to those of most military vehicles. In 2007, DARPA issued a new challenge, navigating through a complex, simulated urban environment. Vehicles will have to simulate a military supply mission through a city, which means they will have to be able to merge with traffic, avoid obstacles, and follow a planned route. The team with the fastest qualifying vehicle will win $2 million. Navigation is one important hurdle to conquer in the pursuit of robotic autonomy. Still, when you want your robot to be able to locate, identify, and fire upon enemy combatants, the stakes are higher. Discovering how to teach a robot to differentiate between enemies, allies, and innocent bystanders could take a long time. Apart from the technical aspect, The sheer cost of robotic research and production is challenging. The DoD estimated in 2006 that the total investment in robotic research from 2006 to 2012 would be $1.7 billion. As war costs increase, budgets become tight, and the Army is forced to sacrifice some of its plans. Many of the military's robotics projects are unfunded, and others are on hold indefinitely. Due to budget cuts, many of the more expensive initiatives included in FCS may need to be postponed indefinitely. The Muley and ARV vehicles fall into this category. As a result, it may be several years before we see U.S. robots being used as combatants in war scenarios. Still, the U.S. military is determined to continue investing in robots, hoping that one day robots can replace human soldiers in dangerous situations. However, ethical questions arise when discussing the use of robotic soldiers. Would a country with an armed robotic force be more likely to invade another country, knowing that there would likely be very few casualties? If a robot malfunctions during a mission, do we risk sending humans to retrieve and repair it? Can we ensure that robots know when to stop attacking when an enemy surrenders? Although we may still be years away from witnessing an effective robotic fighting force, it is important to address these questions today. Scientists and engineers could create better robots by considering these design factors. Otherwise, the fictional battalions of Terminators could become closer to reality than we would like. Thanks for watching. While you're still here, click on the link on your screen to watch another of our interesting videos. See you there.